Continuing on in class 11, just for the sake of completeness, I'll do examples, the example 3.14e. That's really the same as the example I just did in the previous video, except this one is going to be in US units. So we have that same cylinder, or a different version of it. It has initial volume of 2 cubic feet, and it contains nitrogen. And now we're at 20 psi. I'm going to assume it's 20 psia and 80 degrees Fahrenheit. The piston is moved, compressing the nitrogen until the pressure is 160 psia, and the temperature is 300 degrees Fahrenheit. During this compression process, heat is transferred from the nitrogen, and the work done on the nitrogen is 9.15 BTUs. Determine the amount of this heat transfer. So we have to try to figure out what these values are going to be. And so we're going to have to, this is the same problem as it, but with US units. So we'll go for our initial volume. It's going to be 2 cubic feet. And state 1, what we know about it, is the pressure is 20 psia. And the temperature is 80 degrees Fahrenheit, which, by the way, is 80 plus 460, boom, 540 degrees Rankine. Anything else for that one? No. And state 2 is going to be P2 is equal to 160 psia. And T2 is 300 degrees Fahrenheit, and I think that makes what, 760 degrees Rankine, if you wanted to know. And they told us that the work done between 1 and 2 was going to be 9.15 BTUs. I don't know why they're so very specific, no pun intended. And this was on work that was on to the system. So let's look up. We're going to use we're not going to do the other process we did. We kind of made the video longer than it needed to be in the previous one. Let's just go ahead and look up from the tables the constants that we need. So we're going to go to table. This is going to be F.4 for this, because these are US ones, and all those values are in the F tables. All right, so okay, I went to F7, so I gotta go up a little bit earlier. I tabbed the steam table as part of this, but F4, here you go. And looking at this, we have nitrogen right here at the bottom of my thing right here. So the R is 55.15, and the specific heats are 0.249 and 0.178. But look at the units. This is foot-pounds, pounds mass, degree Rankine, and these are BTUs per pound mass, degree Rankine. So to be able to make a comparison between that and this, you need to convert one or the other with that 778.17 constant conversion thing about foot-pounds and BTUs. It's weird. But anyway, we're going to take this R, and we have 55.15 foot-pounds per pound mass, degree Rankine. We'd also find that CP, which we don't need in this problem if we had peeked at the previous problem, is 0.249. These are BTUs per pound mass. CV is 0.178 BTUs per pound mass. And we want to get the mass, right? So we know what the cubic feet of this are. Let's find what the volume is going to be using the ideal gas law. The IGL. Let's use the IGL. PV equals MRT. So we could find what the mass is by dividing the PV by the RT. Careful with the units. Pressure at state 1 is going to be 20 psi, but we need 20 pounds per pounds force per square inch. I turned that, see how I solved that? How I pulled it out of the fire. Well, let's turn that into pounds per square foot, inch squared over feet squared. The volume, which is 2 cubic feet, right? So now we're turning this into feet, so that's going to be compatible with that. And then R already has feet and pounds. Put an F next to that if you wanted to. 55.15, and stick the units in there. We don't need to be unit bravery right now. And then we could put in our 540 degrees Rankine that we had boom boom up there. And so for a mass, we have 0.1934 lbms, pounds mass. Yay for us. Now we can go ahead and find what our, rewrite our big equation. Okay, I just turned that Q into a U. Did you see how I pulled that one out? It's not a very good looking one. So we could say, rewrite this, the Q12, here's the heat transfer, is going to be U2 minus U1 plus 1 to 2, which for us is going to be mCV delta T. It's going to be that U2, the U1 right here, plus work from 1 to 2. And so therefore on here, we're going to go and write our 0.1934 times our CV, which is going to be, this is pounds mass and this is pounds mass, so we're going to be okay with BTUs is coming out right here. I want the CV, sorry. 0.178. That should be degree Rankine up there in degree Rankine. I'm sorry. I must have slipped my mind as I was going through here. So we need to also multiply this by temperature, which we will, and it doesn't matter because it's a temperature difference that we're not using degree Rankine here. And then this is going to be a negative 9.15 BTUs. And what we're going to find here is we get a negative 1.576. So the conclusion, so you go, therefore, heat is removed. So they lied in the problem statement by saying that it just says heat is transferred from the nitrogen. No, I guess it is true. No, that's true. Yeah, negative means heat is removed. Yep, so they didn't lie to us. I'm sorry. I'm going to apologize to the author personally, Mr. Borgnakke, if you're still out there. I'm sorry. You were right. I was wrong. I'm getting punchy. One more example. It's too many examples. One more example. One more. No, there's too many. No, we're going to do one more. Okay, cool.